Here's another trig identities video to help you with your work. The learning goal is still to prove some simple trigonometric identities. In order to do that, we are going to work with a few that are listed here. So we know that cosecant x is equal to 1 over sine x. We know that secant x is 1 over cos x. And cotan x is 1 over tan x. We also know that tan x is equal to sine x over cos x. And cotan x then would be the inverse of, the reciprocal of that. So cos x over sine x. When we prove simple trigonometric identities, we're going to just replace any of these things with sine and cos. This is a very basic Pythagorean identity. Sine squared plus cos squared equals 1. Naturally, it can be rearranged. So for instance, cos squared x would equal 1, and you would bring the sine squared over, so 1 minus sine squared x. Or sine squared x is equal to 1 minus cos squared x. So again, when we see these things, we might be able to replace them. This particular question says simplify, so the first thing I'm going to do is rewrite everything in terms of sine and cosine. In this first line, I looked at cotan x and I replaced it with cosine x over sine x. I noticed that there was a sine x on the top here and on the bottom here that would cancel out or divide out. When I simplified, I ended up with cos x, because these disappeared, so I just have the cos x, minus sine x cos x. So one more step shows me that I can actually common factor out a cos x. So if I divide this cos x by cos x, I get 1. I divide sine x cos x by cos x, and I get sine x. So now then this is the simplified version of sine x cotan x minus sine x cos x. Now we're going to simplify cos x times 1 plus sec x times cos x minus 1. And again, I'm going to substitute everything in sines and coses, which means that this sec x is going to become a 1 over cos x. Okay, so I took the sec x and I replaced it with a 1 plus cos x. Everything else is still the same. At this point, I'm going to divide or multiply the cos x into this first bracket. Cos x times 1 is cos x. Cos x times 1 plus cos over cos x is just 1. At this point, this is just a matter of experience. You might recognize that we have a term plus 1 and a term minus 1. When we see this configuration in binomials, then maybe we would think, or hopefully we'll start to think, that this is a difference of squares. So if this is, I could just multiply it out with the arrows, or I could just use the difference of squares to come to the final answer. Okay, you'll notice I used the blue arrows to do the first two and the green arrows to do the second two. In this case, we have a minus cos x and a plus cos x. And this is that difference of squares that I referred to. So we have a plus b, a minus b, so we end up with a squared minus b squared. We could take this one step further and recognize that cos squared x minus 1 is the same as negative sine squared x by using the Pythagorean identity. This is a proof, so I'm going to set my page up into a left side and right side. So I took the left side of my equation and put it here, and I took the right side and put it here. And the reason I split it into two sides is because it's not technically equal until I prove that it's equal. So I'm going to work with the left side. The right side is as good as it's going to get, simplified into sine. So I'm going to change this tan x into a sine and cos. Tan x is equal to sine x over cos x. So what I now have is sine x over cos x times cos x. So what I'm going to do then is cancel this cos x with this cos x, and then my final answer is sine x. And therefore this identity is true because left side equals right side, and the identity is true. This one looks a bit more challenging. We have tan x plus 1 over tan x equals 1 over sine x cos x. And again, if we're going to be doing a proof, then we need to set our page up in left side and right side. Again, it looks like this side, being in sine and cosine already, is probably as simple as it's going to get. So I'm going to work with this side. For tan x, I substitute sine x over cos x plus 1 over tan x, so the sine x over cos x is on the bottom. What that means is if I have this on the bottom, I can just flip it. 1 divided by sine x over cos x will be the same as cos x over sine x. And at this point, I need to find a common denominator in order to add these two fractions. So this cos x needs a sine x, and this sine x needs a cos x. You notice in yellow, I multiplied top and bottom by sine x for this one to get the common denominator, and top and bottom of this one by cos x. Sine times sine is sine squared, cos times cos is cos squared, and then of course I have the common denominator of cos x sine x. Now I could have written that sine x cos x, so you notice that our denominators are the same. So now I'm going to look at the top again, and I recognize that sine squared x plus cos squared x from the Pythagorean identity is just 1. Therefore, if my left side equals my right side, the identity is true. Your turn. Good luck. I believe in you. And do these videos, please.